Hello and welcome to another Undungeons Devblog. Um, this one might be a little bit longer because there's a lot more content, so let's jump right into it. First major change is improvement to enemy pathfinding. So whereas before they would walk through walls, I'm just gonna see if I can demonstrate. Whereas before they would walk through walls, if they could see you to arrive at your current position, they'll now, as you can see there, hang on, can't see me, path around walls instead of through them. So perhaps here, yeah, so in this situation it probably would have walked through the wall diagonally, but instead it turns and walks properly around the wall. So how does it do this? Well, I'm using the A-star pathfinding algorithm. Discussing the full scope of the A-star pathfinding algorithm is a little bit outside of the scope of this video, but I will leave a link in the description to a useful video for understanding it, as well as the tutorial series that I used for implementation into my game with some fairly major modifications to accommodate the sort of turn-based nature of mine. Okay, so you can see here there's a grid that has been generated. This is purely a debugging tool, so it doesn't appear in the game. But essentially what is happening is that this thing here, this grid script, accepts two values, x and y, 100 by 100, or rather I've given it 100 by 100, and what it's done is it has created a series of objects that are this script called nodes, and each node is like a little, it is like a location in space, as well as a space itself. So it's a little cube that is 1 by 1 by 1 that sits in a location in space. And with that, this script here, the pathfinding algorithm, implements the A-star algorithm. As I say, it would take too long to go through here, but essentially what it does is it tests a variety of locations. So right now, this one would test maybe this way and find that going that way would take it further away than the character. Then this way, find again that it's taking it further away. This way, find that it's taking it further away. Then this way, and it would find, oh, I am getting closer, but before moving, would also test this way and find that this move would get it even closer, and eventually this move would get it even closer than that. It finished testing these two. This one wouldn't be closer than this one, so it wouldn't do it, and then this one would be getting further away. Once it's done that, it does the same thing again, checks down, down to the right, it's already checked left, so it doesn't need to do it again, and then finds that down would get it closest, down to the right would get it closer, but not as close as down, and so on and so forth until it's found the character. And it recalculates this every single time that it has not arrived at the player's last known position. So as you know before, there is some raycasting going on. If I quickly move, you can see there are still these blue lines that are being cast to the character, and this red dot representing the last location where the player was seen, and it is trying to move towards that location. So yeah, that is the new pathfinding system. You can see that these walls here have been tagged with are on the unwalkable layer, which what that basically means is that when the nodes are being drawn, they will check whether there are any objects that are unwalkable on top of them, and if they are, that node will become unwalkable. So you can see here they're highlighted in red, and the player's node is highlighted in green through a similar method. The player isn't using the pathfinding algorithm, but it is using the grid algorithm. So before I had a little collision box in front of the player that just checked constantly whether there was anything in front of them, but now what it does is every time it acts, it pings the grid and checks the direction it's walking in, and if the direction it's walking in would land it on an unwalkable node, it does not walk. So I'll show that here. Cannot move because that node there is red. It might not look from it like it from that angle. Well, in fact, that could probably use fixing, but you get the idea. Right. What else has changed? I've also changed the shooting algorithm. So right now it doesn't actually destroy the enemy for bug testing purposes, but what you'll see here is if I get this guy to get a little bit closer to me, there we go. So right now the character is overlapping, or that rather these boxes are overlapping. If I press Q, I've got there a hit. So before, what was happening is that each one of these reticles had a collision box, which they might still do. Yeah, they do. But I can get rid of that now. And what they were checking to see if there was an enemy overlapping with them. If they were, there was this. The enemy script had a collision on collision enter, which it no longer has, as you can see here. Yeah, so it no longer has a non-collision enter. It no longer has this. I've left the ball here for demonstration purposes. If you remember here in the last video discussed, they have this kill switch, which when they enter goes true, and then if the player shoots while it's true, then they die. Now what's happening instead is that in the main character script, whenever the game manager detects the Q input, and that is the shooting input, it basically checks at each of the locations where the reticles are manually, and it doesn't actually know where the reticles are, but it knows the direction that the player is facing, and it knows how far away the reticles are. So if you see here, it's GameObject.transform.position, which is the players, plus X direction, which is, if you remember here, is a couple of arrays that are tracking the direction that the player is looking in combination with Z direction, multiplied by I. And this for loop has 7, is I less than 7, which will give us 6 iterations. And so it is going to check 6 locations away from the player, including the player space. And if it finds a match, then it will hit. Or rather, not including the player space, just the sorry, it's 5 iterations. Yeah, from the player, because multiplying by I, so multiplied by 1 will be 1 space away in the direction, 2, etc., etc. Probably unnecessary explanation. But yeah, you can see also there's a little bit of terrain. The idea would be, I think, yep, you can get rid of this. Live bug testing. Okay. Yep, you can get rid of these two. Okay. Yeah, so the idea would be, oh, okay. The idea would be, let's say I put a little ammo box here. The idea would be to teach the player that they can outsmart the zombie. So if you go straight for the ammo box around here, zombie will turn around, and as you're trying to run away, bam, you're dead. But because the zombies are stupid, if you go around here and you show the zombie that you're here and then move away, you can grab the ammo box and turn around. Oh, this is going to be close. Is it? Yeah, there we go. And bam. As I said, I haven't implemented the deletion yet, but you see here I got hit, the enemy would die. So the plan is to have very, very limited amounts of bullets, and to have the player have to sort of like run to get bullets. Yeah, I'll be using rooms sort of like this with different camera angles, may implement some different ones, and hopefully in the next video there will be some visuals for you all to see. Yeah, thanks for tuning in again, and I hope this was enjoyable. See you next time.